6a says m equals sets opening bracket n, that's the element n, full colon 2n minus 3 is less than or equal to 37, where n is a counting number. Write down all the elements in m. That's 1. 2, Roman figure 2. If a number is selected at random from m, what is the probability that it is a multiple of 3, b a factor of 10? So for the first question, this m means n, and the value of n they're talking about is 2n minus 3 is less than or equal to 37. This is like an equation we have to solve for n to know what our m is. So let's write it out. 2n minus 3 is less than or equal to 37. We have 2n less than or equal to 37. The minus 3 goes out and becomes plus 3. This is also a form of equal to sign. So when the minus 3 crosses the sign, it becomes plus 3. We have 2n is less than or equal to 40. That's 37 plus 3. Divide both sides by 2. N is less than or equal to 20. So our m is equal to n, which is n is less than or equal to 20. So our m will be all numbers. Since they are counting numbers are all positive numbers, excluding 0 and negative numbers. So we mean positive whole numbers, like we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. These are all values for m. So the total outcome is 20. The second question says, write down all the elements of m. That's the first question. All the elements of m are 1 to 20. Now that we have figured out all the elements of m, we can now answer the second question that says, if a number is selected at random from m, what is the probability that it is a multiple of 3? So we have to know all our multiples of 3. Multiples for the first one, a. As multiples of 3 are, you have 3 itself, as numbers that you multiply by 3, like 3 times 2 is 6, 3 times 3 is 9, 3 times 4 is 12, 3 times 5 is 15, 3 times 6 is 18, 3 times 7 is 21, and 21 is greater than 20, so you can't fit into this, so we'll stop at 18. The question is, what is the probability that it's a multiple of 3? So these are multiples of 3. Probability of a multiple, m of 3, that's multiple of 3. We'll count the number of, that will be total number of multiples of 3 over total outcome. That's probability multiples of 3 or multiple of 3. It's a multiple of 3. It's total numbers of multiples of 3 over total outcome. The numbers of multiple of 3 are 1, 2, 3, 4, 5, 6. There are 6 of them. Over the total, when we count all the counting numbers, there are 20. That's 6 over 20. We call to the lowest term, we have 2 here, 3, 2 here, 10. Our answer is 3 over 10. The B part of the question says, if the number is selected at random from m, what is the probability that it is a factor of 10? So B will find all factors of 10. All factors of 10 are numbers that can divide 10 and you get a whole number, which are 1. You can take 1 times 10 is 10. You can take 1 and 10. You can take 2 times 5, that's 2 and 5. And 3 can go, 4 can go in 10 without remainder. Already chosen 5, 6 can go 7, and all numbers greater than 10 will give you decimals. So factors of 10 are 1, 2, 5, and 10. So probability it's a factor of 10 is going to be numbers of factors of 10 over total outcome, which is numbers of factors of 10 are 1, 2, 3, 4. So we have 4 of them over the total outcome, which is 20. We cut to the lowest term, 4 here 1, 4 here 5. Our answer is 1 over 5.